So hello friend, today we are discussing about this brake rendering test. What is brake rendering test? Brake rendering test is ensuring when ship is alongside in safely and securely moved to the berth by mooring ropes. When suddenly load change due to the adverse condition of the weather or something happen, then mooring winch brake start to slips rather than ropes get apart. So brake is adjusted in such a way that it start to slips rather than ropes get apart. So it is safeguard the mooring ropes. So it is called brake rendering. So brake rendering test is a calibration test of the mooring winch corresponding to the minimum braking load or minimum braking strength of the ropes, which is designed for the mooring equipments. So this minimum braking load or minimum braking strength of the rope, which is designed the mooring equipment, is called the ship design minimum braking load. This test is important because of prevent the accidents, prevent the damage to the mooring equipments and fatalities. So here when designing stage of the ship, starting ship design minimum braking load 100% considered by the classification society. After, on the basis of this load, we can decide our motor capacity 50% of the SDMBL. Then we check the brake holding capacity. This one designing maximum brake holding capacity 80 to 75%. And this operational minimum brake holding capacity 60% of the SDMBL. It is ensure the brake rendering load capacity. In this load, we are testing the brake rendering, brake start to slip. So here table also you can see 50% of the winch motor rendering maximum stall, 60% operational minimum brake holding capacity, in which we are testing normally brake, the mooring winch, maximum brake design capacity 75 to 80% and load, setting maximum, then ship design MBL 100% and 105 is mooring ropes. On more than this, mooring fitting strength is more than all minimum braking load of the rope. So before rope break, this mooring fitting strength must be more, otherwise danger. So now you can see this mooring drums is two types, split type, non-split type, divided or undivided. Split type means this one drum, it is divided by the two part by the split flange in between them. You can see in between a split flange which is divided two. So this rope is wounded here and going to other side also. In this system, only this one drum is there, so there is no split type. There is no split flange. So 1 inch is rounded here. Now we go for the test procedures. Now you can see here drum. This is the divided ones, a single rope. Tension in the rope is going this direction, brake is going opposite direction. So when maximum tension of the rope or this brake holding capacity must be same. So this maximum tension, not the 60% of the maximum designing load. 60% of the maximum designing load, this equal to the brake holding, brake rendering. So on the 60% of the maximum tension, it is equilibrium to the this brake. So now what we are going to do, this is the length R, here is the tension torque T, this one minimum tension, 60% of the tension is called the minimum tension. This R we can calculate, capital D is the total diameter, small d diameter of the rope, so capital D plus small t, diameter of the drum, capital D less small d divided by 2. It is equal to this rendering test we are doing by this special tools. in this hydraulic checking system. Here force F and this length L. So F into L equal to T multiply T plus 2 divided by 2. So here we can check a force F equal to T into D plus T divided by 2L kilonewton. This is checking load we require because this force is equal to the braking force but it's in opposite direction braking load. So basically what we are doing this one, we are doing this force. So here what is the procedures? First this split flange we putting this special tool. After we start to jacking, jack and brake is tightened by hand, motor is off, power is off. Then we start to jack and this when brake start to lose, start to slip, that force, that pressure we require for this. Pressure we get from this pressure gauge, then this area we multiply, then we get force. The force into L equal to T into D plus D divided by 2, all equal. We know all the values. Then L we can calculate by measuring the measuring tape. So here we will get all the things. So here easy calculations. Here you will see there is no split flange, so outer side of this flange drum, we put this special tool. Brake is this side, then this force is this side. But here the one different trick that here is the multiple layer, single layer, double layer, triple layer, fourth layer. First, second, third, fourth layer won't because of this undivided. Undivided rounded off this means maximum distance CPC part, then this layer is minimum. If less distance, this layer is maximum. So here brake also changes. So here we are cannot calculate. So you see this radius, this is nearby radius. So this one, if radius, how much you calculate? So torque T equal to tension into R. So here, if radius less, then tension must be more. So nearby is T1 equal to more, T2 equal to less, then T3 less, T3 less. So when increasing this layer, tension also increasing rope. When tension decreasing, when rope layer increasing, tension decreasing. When tension decreasing, brake holding capacity also decreasing. So this brake rendering capacity also decreasing. So this brake rendering capacity below the 60% or more less than the 60% coming because here is multi-layer. So when layer increasing, this brake also capacity decreasing. You calculate this distance is first layer distance d plus d by 2, capital D plus small d divided by 2. Second one, capital D plus 3 multiply small d divided by 2. So here you can get going when R is increasing or T is reducing. But here we cannot fix according to this how much this rendering brake load. Here we cannot calculate the brake load, but here easily we can calculate brake load. This is the main difference. So here we cannot signify. So there only we contact with the manufacturers or factor of safety what we are doing. You can see here I already told about this T plus T divided by 2T torque tension. Here length L1, L2, L3, L4, L1 divided 2, L2, L3, L4. Tension you can check T1 greater than T2, T3, T4. So you check here. Here we need indicator to fix the position. Split one. So which one correct indicator? Here must be no have indication. Indication must be behind it. So it's not hindrance any procedure of the brake. So this wrong, this wrong, this one correct, this one correct. Here you can put indicator. But indicator you can put only the split one because and split one you cannot put indicator because you don't know the how much we brake holding this capacity. brake rendering capacity, operational minimum brake holding capacity also. We don't know. So basically we only split one we can do. After split one data we can measure this drum number, how many rocks there. Then this SDM first layer one we already given the manual. Then SD has shift design minimum braking load we given this equipment manual, mooring equipment manual. Drum diameter already giving, rope also giving. Distance of center line we can calculate by this measuring tapes. Then this operational minimum braking holding capacity 60% we can calculate this. This one tension, one maximum tension. And Jacob force. Jacob force 80% SDML. This one theoretically is maximum jacking force. Calculated hydraulical pressure of the P and actual we are getting here. So jacking force we calculate by this T divided by L into T. This one T DOD L we know, and we can easily calculate this. So Jacob force we already calculate from this calculation. After this pressure, actual pressures, rendering value. We calculate this rendering value of which rendering value we are doing this. And how much percentage of this HTML we check here. Thank you.